Okay, the velocity of a particle is given by this function, and notice it is v of t. The graph of the velocity is below, so we know what that graph looks like, but we've also seen it right here. And then it says how far did the particle travel from 1 to 5. So really, let's go back a few lessons. Exploring the area under a curve, even though it's not a curve, it's a line, right? It's the same idea. So if we had the velocity and found the area under velocity, we would get the total number of miles traveled. This should look very familiar if you've done a previous lesson like this. And so we are going to find the distance that was traveled by finding the area under the velocity curve from 1 to 5. We're going to represent it differently though. So here we go. The integral from 1 to 5 of v of t dt. So what we're really finding right now is this area right here from 1 to 5. This graph represents my velocity, and the area under a velocity graph gives me my distance traveled. So we're going to do this the same way we just did the other problems. Here we go. From 1 to 5, my velocity is negative t plus 5 dt. And then we are going to figure out what the antiderivative would be. And again, there's a lesson devoted to this later, but in the meantime, let's just work our way through it, think logically. The derivative of something gives me, let's ignore the negative. The derivative of something gives me t. Well, it must be t squared. And I need a coefficient here that when multiplied by 2 would give me negative 1. So something times 2 gives me negative 1. Well, it must be negative. And something times 2 gives me 1. It must be a half. There we go. Now we'll do the second term. 5. The derivative of something is 5. Oh, it must be 5t. There we go. And we're going to figure this out from 1 to 5. So we're going to plug in a 5 into all our t's, plug in a 1 into all our t's, crank out those answers and subtract them. So negative 1/2 times 5 squared plus 5 times 5 minus, do that, and then negative 1/2 times 1 squared plus 5 times 1. And here we go. We're going to have, let's see, that's 25 times negative 1/2 plus that 25. I don't know if you can hear this, but someone's being sung to across the hall. They're singing happy birthday to them. I think I'm going to get really cranky and walk across the hall and just tell them, no, there are no birthdays. I'm making a math video. Anyway, 5 times 1 and then negative 1/2, so that'd be 4.5. All right, so 12.5 minus 4.5 is going to give me, well, 8. And this had better turn out to be 8, and it is actually. Based on the area of a triangle, we have base, which is 4, height, which is 4. Multiply those, you get 16. Half of that would be 8. All right. Okay, well now we're getting into a slightly different territory. How far did the particle travel for 1 to 7? So now things get a little bit trickier, and we need to consider the distance that was traveled from 1 to 7 as well. There we go. Notice that I colored it in red. So if I'm talking about how far I traveled, I don't need to say, oh, negative distance. I realize that velocity is going to imply direction. So finding this area is going to give me a positive, and finding this area is going to give me a negative. But if I was to say, and I'm going to write some stuff that's wrong, but then I'll correct it. If I was to say, I'm going to find the area from 1 to 7 of my velocity, then I would really be ending up with this area minus this area, because it's negative, and that would not give me a full representation of the true distance this particle traveled, right? So we're going to do something a little bit different. We're going to pretend that this is positive, and the way we do that is by taking the absolute value of that. Okay? So here's what just happened. In the real world, what we would have done, we would graph this where it bounces off the axis and comes back up, and it would look like absolute value, because it is. And that would give us a representation of this distance plus this distance, and it would be counted as positive. So in order to do that with the tools that we've been given, what we really need to do is this. We're going to split this thing up. we're going to split it up into the stuff that was logically positive and the stuff that was automatically negative, and then we'll deal with it from there. So this is really going to be the integral from 1 to 5 of v of t dt. Am I absolute valuing this? No need, it's already positive. And then we are going to add, I'm going to hold off on my sign for a second, from soup, not 6. I almost said 6 and 5 at the same time. It came out as soup. 5 to 7 of v of t dt. Okay, so let's figure out what to do with this. I would love to say, oh, we're going to absolute value this. I hear you, we can. But basically, I'm just trying to make it positive. So do that. All right, so here's what's happening. Automatically, this would have been negative. But if I subtract it, it'll make it positive. So this is the equivalent of that. Now, we're going to keep going with this idea. And let's realize something. You already figured out this answer right here. From 1 to 5, the area, which was the distance traveled, was 8. 8 what? I don't know. Miles, inches, farthings, I don't know. And then minus, we'll go ahead and take an antiderivative of v of t. Again, we already did it once right here. And we're going to evaluate it from 5 to 7. So here goes. Negative 1/2 t squared plus 5t evaluated from 5 to 7 this time. Okay, running out of space. I should have given you a little more space on this, I'm sorry. 8 minus a whole bunch of stuff that's about to happen. This is going to be confusing if we don't watch our signs very carefully. We're going to plug a 7 into both of those. We'll have negative 1/2 times 7 squared plus 5 times 7. And then we're going to have minus, now I'm going to get carried away with my signs here. There's a mistake that's about to get fixed, so hang tight. We're going to plug the 5 in. Negative 1/2, 5 squared plus 5 times 5. All right, here's what happened. We are going to subtract this entire operation. Subtracting this entire operation means I subtract all of this. I'm getting crazy with the parentheses here, which really means that this part gets added. Okay? We're running out of space, so I'm going to, well, running out of space. So I'm just going to do it. 8 minus, when we figure this one out, we have, oh dear, I left my calculator on the other side of the room, but we'll be all right. 35 minus a half of 49. 35 minus half of 49. Sorry, you don't see any action that's happening right now because I'm writing on a separate piece of paper. Half of 49 is 24.5. 35 minus that. Oh, why don't I just show you here? Oh no, now you know the answer. 35 minus half of that, so 11.5? Yes. No, 10.5. Yeah, 10.5. 10.5 minus, okay, this part right here was 12.5. But I'm subtracting all of this. So that gives me negative 2.5. Something feels very wrong about this. I feel like I've made a tragic mistake. I'm not going to start this whole video over. I'm going to go grab a calculator real fast. And I'm back. All right, here we go. Skip to the next couple seconds of this video if you would like. Obviously, I forgot how to use a calculator. I'm typing this in. Negative 0.5 times 7 squared. There we go, got it. Plus 5 times 7 is indeed 10.5. Done. We're subtracting that. Then we're also going to have negative 0.5 times 5 squared plus 5 times 5, which is 12.5, which is right. We're subtracting that. 8 minus 10.5 plus, it's going to give me 10. Okay. That is indeed correct. So what I had gotten previously was, well, incorrect. Oh, yeah, and that makes sense. Okay, yeah, good learning opportunity. My previous answer key was wrong. Okay, here we go. This is 8. This is 2. 8 plus 2. Let's not make it harder than it is. Sorry. All right, what's the displacement? Whoa, displacement? Displacement, what does that mean? Okay, here's what that means. The particle was moving, and I'm going to be talking forward and backward as I deal with positive and negative, okay? The particle was moving forward, then the particle was moving backward, right? Okay? So the particle moved forward 8, and then it moved back 2, which means if it moved forward 8 and then back 2, it really moved 6 to the right, 6 forward, okay? We could do it this way, 1 to 7, v of t dt. And in the process of doing this, we will automatically take care of everything that's positive, everything that's negative. So we're going to do it this way. So we have, let's see, integral of v of t, which we've already found to be negative 1/2 t squared plus 5t. Negative 1/2 t squared plus 5t. And that goes from 1 to 7. Negative 1/2 7 squared plus 5 times 7 minus negative 1/2 1 squared plus 5 times 1. And that's going to give me this guy right here, which we found out a minute ago was 10.5. This one right here is 4.5, which is indeed going to give me 6, and it makes sense. The displacement of the particle is 6. Positive 6, meaning overall, this particle moved more forward than it did backward.